Good morning. This lesson is for my integrated 1 classes, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of is that we're going to go over the Unit 2 test so that we can do much better when we retake the test. So let me go ahead and just show you the steps that we're going to use to solve inequalities in graph. So our first step is going to be to eliminate fractions by multiplying everyone by the denominator. Our second step is going to be to distribute. Our clue is parentheses. Our third step is going to be to combine like terms on each side of the inequality symbol. Our fourth step is going to be to get all variables to one side of the inequality symbol using addition or subtraction. Our fifth step will be to add or subtract away a number from the variable side of the inequality symbol. My clue is there's a plus or minus between a number and a variable. Our sixth step will be to divide away a number from the variable side of the inequality symbol. If you divide by a negative, you must flip the inequality symbol and find the graph. Here are our rules for graphing. These symbols mean left of, these symbols mean right of, these symbols mean open circle, these symbols mean closed circle. And remember, we treat greater than and less than as right of and left of. And instead of saying X, we say the phrase the shading. So here I have 3 of the 14 problems on the board. I'd like to go through these and show you how we're going to solve them and use these steps and use this chart to answer the questions. All right. So problem 1 is 4 plus x is right over at negative 2. I'm going to go ahead and write my 1 through 7 and just go down the line. If I can do it, I do it. If not, I move on. Do I have a fraction to eliminate? No, I do not. Can I distribute? Meaning, do I have parentheses? No, I do not. So I can't. Can I combine like terms on each side of the inequality symbol? Can I put these together? No, I can't because they're not like terms, and there's no one to combine with a negative 2. Step 4. Can I get all x's to one side of the inequality symbol? I don't need to because they're all on the left side. Step 5. Do I have a plus or minus between a number and a variable? I have a plus between the 4 and the x on the variable side of the inequality symbol. So I can do step 5. And I'm going to add or subtract away that 4. That is a positive 4, so I need to subtract away the positive 4. That cancels out. I'm left with my x. That's right over at. I owe you 2, I owe you 4, so I owe you 6. All right. We don't need to do step 6 because x is already by itself. Now I need to do step 7, which means I'm going to graph. So this says the shading is right of negative 6. And we're going to have a closed circle at negative 6. So there's my negative 6. My circle is closed because I have that symbol. And I'm going to shade to the right. The shading is right of negative 6. So translate that. Treat it like a sentence. A little bit easier to understand in words that we use every day. So that is what I'm looking for on problem 1. Problem 1, I want to see that you can do step 5 and step 7 with a variable on the left side. Problem number 2. Let me use some color in here so it's a little easier to follow along and it will differentiate the problems. Problem 2. 1, 2, 3, 4, 5, 6. You don't have to write 1 through 7 if you know the steps, but this is for those students that are struggling with what to do first and what to do next. Remember, this answers that question that was asked many years ago. Step 1, can I eliminate the fractions? No, I cannot. Step 2, do I have parentheses so I can distribute? No, I do not, so I can't do step 2. Step 3, am I allowed to put x minus 2 together? No. And no one to put together with a 6, so I can't do that. Step 4, do I need to get all variables to one side? No, I don't, because all my x's are on one side. Step 5, do I have a plus or minus between a number and a variable? I have a minus between a 2 and an x, so I can do step 5. I can add away the negative 2. So I'm going to add 2 to both sides, getting the x by itself. Those 2's cancel. 6 and 2 give me 8, and 8 is left of the shading. I don't need to do step 6 because there's no number with the variable, but I do need to do step 7, which is the graph. And again, I'm going to translate it. 8 is left of the shading. So I'm going to put an open circle at 8 because that's what that symbol means. Open circle at 8, so open circle. And I have to shade on the right so that 8 is left of the shading. And remember, the shading is where all the solutions to our original inequality are. So 8 is on the left of the shading. So that's what I'm looking for in problem 2. Again, I want to see that you can do step 5 and step 7, this time with a variable on the right side of the inequality symbol. All right, I gotta make sure I got a good marker, not that one. Maybe this will be good. Okay, that's good. All right, so let me jump into problem number 3. 1, 2, 3, 4, 5, 6, 7. And before I continue, let me remind you, you're going to get a half point for solving and a half point for graphing. So I want to see both on this test. Okay, problem number 3. Do I have a fraction to eliminate? No, I do not. Do I have parentheses so I can distribute? No, I do not. Can I combine like terms? No, there's no one with a negative 5x on the left, and there's no one with a 15 on the right. And my x's are all on the left side, so I can't do step 4. Can I add or subtract away the negative 5? No, I can't, because there's no plus or minus between the number and the variable, so I can't do step 5. So I must do step 6 to solve this. Now, make sure we understand all the directions of step 6. Divide away a number from the variable side of the inequality symbol. If you divide by a negative, flip the inequality symbol. Remember, when you change signs of numbers, you change their position. And when you change their position, you have to change how you describe their position. So it was on the left, now it's on the right. So that's why we flipped that. Just a quick reminder. So we have to divide both sides by negative 5. Those cancel out, and x is now, or the shading is now right of, negative 5 goes into 15, negative 3 times. So the shading is right of negative 3. And according to my chart, I have a closed circle. All right, so at negative 3, my circle is closed, and the shading is on the right of that. Okay. So that is how I do problem number 3. And problem number 3, I'm looking to see that you can do steps 6 and 7 with a variable on the left side. So I'm going to go ahead and clean this up and write the next 3 problems for this review for our test. And let me clean this up, and I'll be back. I'm back, so let's go ahead and continue with this this review. So here we are on problem number 4. Again, I'm going to write the 7 steps to solve. 1, 2, 3, 4, 5, 6, and 7. And let's go through step by step. Step 1, can I eliminate a fraction by multiplying everyone by the denominator? Yes, I can. I have a fraction, so I need to eliminate that. So I'm going to multiply this number by 3, and I'm going to multiply this number by 3. 3 times 5 is going to get me to 15. And these 3's are going to cancel, and so 15 is right of the shading. There's no parentheses. I can't combine like terms. All my x's are on one side. There's nothing to add or subtract away. There's nothing to divide away. So now I need to graph. And again, 15 is right of the shading. Let me put that in there. So there's my 15. According to my chart, it's an open circle. And I have to shade on the left because 15 is on the right of the shading. So there's my shading, and 15 is on the right side of that. So that's what I'm looking for on problem 4. I want to see that you can do step 1 and step 7 with a variable on the left side. Moving on to problem number 5. I got my numbers. Problem number 5. Again, I'm going to write my steps 1, 2, 3, 4, 5, 6, and 7. And again, these steps are to help you know what to do first and know what to do next. All right, so step number 1, can I eliminate fractions from this problem? No, I cannot. Step 2, can I distribute? I know that I can't because I don't have parentheses. Step 3, can I combine like terms on each side of the equal sign? I'm not allowed to put together minus 5 and minus 2x because that doesn't have an x, so they're not like terms. Now, there's no x there. These would be like terms, but I don't have like terms, so I can't do that. And there's no one on the left to combine with the 7, so I can't do step 3. Step 4, do I need to get all variables to one side? No, I do not, because all my x's are on the right side. Step 5, can I add or subtract away a number from the variable side of the inequality symbol? Meaning I have a plus or minus between a number and a variable. My minus 5 is that number. So to get rid of that minus 5, I'm going to have to add 5 to both sides. So plus 5 and plus 5. So that negative 5 and positive 5 cancel. 7 and 5 are going to get me to 12. And 12 is left of negative 2x. I still have a number with my x, so I have to do step 6, which is to divide away a number. And again, I'm dividing by a negative, so I'm going to have to flip that inequality symbol. Make sure you're paying attention to that. If you're dividing by a positive, You do not have to flip it, but we're dividing by a negative. 12 divided by negative 2 is going to get us to negative 6. And negative 6, ooh, I almost made the mistake. Negative 6 is now right of the shading. So let me put a negative 6. My circle is open according to my chart, and it's saying negative 6 is on the right of the shading, so I have to shade on that side. So for problem number 5, I'm looking to see that you can do step 5, 6, and 7 with the variable on the right side of the inequality system. All right, problem number 6. Let me write my 1 through 7. And just go through step by step. Step 1, can I eliminate a fraction? Yes, I can. I have a fraction right there, so I'm going to follow what this says, and I'm going to multiply everyone by the denominator. That means I'm going to multiply negative 3 and 4 and x over 2 by my denominator, which is a 2. So you get a 2, you get a 2, and you get a 2. Negative 3 times 2 is going to give me to negative 6. Negative 6 is left of 2 times 4 is going to give me to 8. Those cancel out, and I'm left with a plus x. Step 2, do I have parentheses? No, I do not, so I can't distribute. Step 3, can I combine like terms on the right? Nope, and no one to combine on the left, so I can't do that. Step 4, can I get all my x's to one side? I don't need to because they're all on the right side. Step 5, can I add or subtract away a number from the variable side? Yes, I can, because I have a plus between my number and my variable. That's a plus 8, so I can get that 8 to the other side by subtracting it away. So I'm going to subtract away that positive 8, and I'm going to be left with, let's see, I owe you 6, I owe you 8, you're going to tell me I owe you 14. And 14 is left of the shading. I don't need to do step 6 because x is by itself, but I do need the graph. So let's see here. I'm going to go open circle at negative 14. And negative 14 is left of the shading. So what that means is I need to shade on this side, and my negative 14 is on the left of the shading. So this problem, I'm looking for step 1, step 5, step 7 with my variable on the right-hand side. So hopefully you understand what I did with these 3 problems. I'm going to go ahead and clean these up and work on the next 3. So let me clean all these up, and I'll be back. Back, so let's go ahead and continue with this here. We're going to work on problems 7, 8, and 9, and again I'm going to use my 7 steps as well as my chart to help me solve the inequality and graph the solution. So here we go. I'm going to write 1 through 7, so I remember to go through my steps in order to solve this. Step 1, can I eliminate a fraction? Yeah, I got a fraction in this problem, so I'm going to multiply everyone by the denominator. So that's my denominator, so I'm going to multiply that or put it next to every number. Like so. The 3 and the 3 cancel out. I'm left with an x plus my 2 times 3. That gets me to a 6. And that's greater than or equal to my 1 times 3, which is a 3. Step 2, can I distribute? Meaning I have parentheses. No parentheses, so I can't distribute. That was step 2, not step 3. Step 3, can I combine like terms on each side of the inequality? Can't put those together. No one to put together with the 3. So I can't do that. Step 4, get all my variables to one side. Well, they're all on the left, so I can't do that. Step 5, can I add or subtract away a number from the variable side? I can, because I have a plus or minus between my number and my variable on the variable side, so I can do step 5. I can make the plus 6 go away by subtracting it to both sides. And now I'm left with the x is right of, or the shading is right of. If I have 3, I owe 6. That means I still owe 3. So the shading is right of negative 3. Don't need to do 6 because x is by itself. Do need to do 7, and that's the graphing part. So remember, half a point for solving and a half a point for graphing. I'm going to put a shaded circle or closed circle at negative 3, and I'm going to shade to the right of negative 3. So this is what I'm looking for problem 7. I want to see that you can do step 1, step 5. That's supposed to be an x. Step 1, step 5, and step 7. All right, let's move on to number 8. Again, I'm going to write my 1 through 7 to remind myself that these are the steps that I'm going to follow in order to solve this thing and graph it. Can I eliminate a fraction in problem 8? No, I cannot. Can I distribute in problem 8? No, I cannot. Can I combine like terms on each side of the inequality symbol? No, I cannot. Can I get all variables to one side? I don't need to. Can I add or subtract away a number from the variable side? Meaning I have a plus sign between my number and my variable. Yeah, 5's got a plus sign between it and the variable. So I can do step 5. Since it's not marked as negative, it means it's positive. So I need to subtract the 5 to the other side. Cancel that out. I'm left with a 3x is right of 17 take away 5 gets me 12. I can divide away the 3 because I'm left with the 3 after step 5. The 3 with the x, sorry. I'm not dividing by a negative, so I do not need to switch this. So this stays the same. Those cancel out, and 3 goes into 12 4 times. The shading is right of 4. The shading is right of 4. So for problem number 8, I want to see that you can do steps 5, 6, and 7. Problem number 9, again, write my steps 1 through 6. 1 through 7, and let's go ahead and go through this. Can I get rid of a fraction? No, I cannot. Can I distribute, meaning I have parentheses? I can distribute. Now pay attention to the sign. I got a negative 2 times an x. That's negative 2x, and a negative 2 times a negative 4. That's going to get me to an 8. So here I have 12 is right of minus 2x plus 8. Can I combine like terms on each side of the inequality symbol? Nope, and nope. Do I need to get all x's to one side? I don't. They're all on the right side. Can I add or subtract away a number from the variable side of the inequality symbol? Meaning I have a plus sign between my number and the variable. That's the number that I need to add or subtract away. So I'll minus the 8 to both sides. That cancels out. 12 minus 8 is 4. 4 is right of negative 2x. I need to do step 6 to isolate the x because it's not by itself yet. And again, I'm dividing by a negative, so this switches. A negative into a positive is a negative. 2 goes into 4 2 times. Those cancel out, and that's what I'm left with. I need to graph this now. Negative 2 is left of the shading. So let's put the negative 2 there. Let's put our shading. Well, it's an open circle. Remember that. And since negative 2 is on the left of the shading, that means that the shading is on the right of the negative 2. So here's what I'm looking for problem 9. I want to see that you can do 2, 5, 6, and 7 with the variable on the right side of that inequality symbol. I don't know, that was a TikTok. Let me go ahead and clean up 7, 8, and 9, write out the next few problems, and I'll be back. I'm back, so let's go ahead and finish 10, 11, and 12 in this review for this retest. Again, I'm going to write 1 through 7 to reinforce the concept that I'm going to use the steps to solve this inequality that I'm going to graph. So step 1, can I eliminate a fraction? There's no fraction, so I don't need to eliminate. Step 2, do I have parentheses so I can distribute? I do have parentheses, so I can distribute. We're going to say 4 times x and 4 times 2. 4 times x is 4x, and 4 times 2 is 8. 4x plus 8 is left of 8. Can I combine like terms on each side of the inequality symbol? No, I cannot. Can I get all x's to one side? I don't need to do that because they're all on one side. Can I add or subtract away a number from the variable side of the inequality symbol, meaning I have a plus sign between a number and a variable? I do have that. I have a plus 8, so I'm going to make the plus 8 go away by subtracting it to both sides. Minus 8, minus 8. That cancels out. I'm left with a 4x is left of, let's see, 8 minus 8 is 0. 4x is left of 0. I need to divide away the 4. So we're going to divide away the 4 to both sides. And here I'm left with the shading is left of 0. You have nothing to share with 4 people. Each person gets nothing and they like it. I didn't have to switch this because I did not divide by a negative. So I have my shading is left of 0 with an open circle. So there's my open circle at 0, and I'm going to shade to the left. So for problem number 10, I'm looking to see that you can do steps 2, 5, 6, and 7 with the variable on the left side of the inequality symbol. So that's what I want for number 10. Number 11. Here we go. 1, 2, 3, 4, 5, 6, and 7. Do I have fractions to eliminate? No, I do not. Do I have parentheses so I can distribute? No, I do not. Can I combine like terms on each side of the inequality symbol? I can't put these together, and there's no one to put together on the left side. Remember, it's on each side, not going across. That's what step 4 is about. Step 4 is getting all the variables to one side. I have variables on both sides, so step 4 I need to do. So I'm going to move the 5x to the other side. You wouldn't be wrong if you moved the 2x over, but then you would be adding an extra step to the problem. Alright, so I'm moving the variables to one side of the inequality symbol by addition or subtraction. I cancel that out. 2 minus 5 is going to get me to minus 3x. That's left of 21. Can I add or subtract away that minus 3? No, I cannot, because there's no plus or minus between that. Can I divide away the minus 3? Yes, I can. So I'm going to divide both sides by minus 3. Those cancel out. X is, I'm going to have to switch that because I divided by a negative. The shading is right of 3 goes into, negative 3 goes into 21, negative 7 times. So the shading is right of negative 7. So there's my negative 7. It's an open circle and I shade to the right. So for problem number 11, I'm looking to see that you can do step 4, 6, and 7 with variables on both sides. All right. Problem number 12. Now it's not by accident that the numbers in these problems are the same. The only difference is the position of the inequality symbol and the plus sign, that those are switching in the problem, because I want to make sure that you understand the difference between step 3 and step 4. So 1, 2, 3, 4, 5, and 6, and 7. And 6 and 7. Do I have fractions to eliminate? No, I do not. I don't have parentheses, so I cannot distribute. But I can combine like terms on each side of the inequality symbol. These are on the same side of the inequality symbol, so I can put them together. So I now have 7x is left of 21. So I did step 3. Don't need to do step 4 because all the x's are on one side. I can't do step 5 because there's no plus or minus between the 7 and the x. So I must do step 6, which is divide away the 7. Now again, I'm dividing by a positive, so my inequality symbol does not flip. My 7's cancel out, and I get that the shading is left of 3. The shading is left of 3. Open circle at 3, and I shade to the left. All right, so this is what I'm looking for in problem 12. I want to see that you can do step 3, 6, and 7 with both variables on the left side. So hopefully this is making sense to you. So I'm going to go ahead and clean this up for the last time, and I'll be back. I'm back for the last time, I promise. So let's go ahead and finish the last 2 questions on this test so we can review this and ace this and bring up our grades and not have to have a good grade and pass this class. All right, so problem number 13, I'm going to write my 1, 2, 3, 4, 5, 6, and 7. Okay, so this one's a little trickier than the previous one. Now notice that I have 2 fractions here. And when we have 2 fractions, what we want to do is we want to cover up one of the different denominators. Ignore that for the time being. And that's supposed to be a hand, but I'm not very good at drawing. But regardless, I'm going to go ahead and do step 1 and eliminate a fraction here. I'm going to multiply everybody by this denominator, ignoring the other denominators so I don't get confused on what to do. So in the first fraction, my fractions cancel, and I'm left with my 5x. 4 times x gets me to minus 4x, and 2 times 4 gets me to 8. Now remember, I was hiding a 2, so I can do this step again. So we're going to go through and multiply everybody by 2. So we're going to multiply u by 2, multiply u by 2, and I'm going to multiply u by 2. I now have my 10x. That cancels out that 2 minus my 4x, and that's right of 16, because 2 times 8 is 16. Can I distribute it in this problem? No, I cannot. Can I combine like terms in this problem on each side of the inequality symbol? Yes, I can. I can put these together. So I have 6x is right of 16. can I get all my variables to one side of the inequality symbol? I don't need to, because they're all on the left side. Can I add or subtract away a number from the variable side? Nope, because there's no plus or minus between those, so I can't do that. So that means I must divide away that number, so I'm going to divide everybody by 6. That cancels out, and I'm left with the shading is right of 16 over 6. It doesn't matter that we have a fraction here, because we just know that the shading is right of this number with an open circle. So we're just going to put that number on our graph, put an open circle, and we're going to shade to the right. So that's what I'm looking for. That's what I'm looking for problem 13. I want to see that you can eliminate two fractions, combine like terms, divide away a number, and graph. So that's what I want to see for problem number 13. All right, problem number 14, last problem. All right, so can I eliminate fractions in this problem? No, I cannot. Can I distribute in this problem? Do I have parentheses? Yes, I can, because I have parentheses. So I have 4 times x, that gets me to 4x. 4 times negative 3 gets me to negative 12. Left of negative 2 times positive 5 is going to get me to negative 10x. And negative 2 times positive 6 is going to get me to negative 12. Step 3, can I combine like terms on each side of the inequality symbol? Can't put those together, can't put those together, so I can't do step 3. I can do step 4, which is to get all variables to one side using addition or subtraction. I'm going to add 10x to both sides and move that to the other side here. So plus 10x, plus 10x. All right, that cancels out, and I'm left with 14x minus 12 is left of minus 12. So I just did step 4. Step 5, can I add or subtract away a number from the variable side? Yes, I can add away a 12 because I have a minus between a number and a variable. So I can get rid of that minus 12. So I'm going to add that to both sides. Plus 12, plus 12. There we go. So that cancels out. I'm left with 14x is left of 12. Minus 12 plus 12 is 0. I have to divide away that 14. And the shading is left of 0 because 14 goes into 0 times. So let's go ahead and graph this. There's my 0, open circle, and I shade to the left. And that's the last problem on this review. On problem 14, I want to see that you can do step 2, 4, 5, 6, and 7. And hopefully this all makes sense. So you should know what problems you need to do. We went over those in class. I told you specifically what problems you need to do. And so hopefully if you're struggling with any of these, you see how we work them out and they make a little bit more sense. So I'm going to go ahead and end this one here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Oh, that was terrible. Have a great day, everybody. Bye-bye.